Yes, sir.
Now mathematics, observe very carefully. For example, you want to convert the 0.3 into a proper number. What you people will do, guys? What you will do? Everybody,
So 3 by 10.
you will write it as a 3 by 10. How will you write the 3 by 10? We'll multiply both numerator and denominator with what? Same number. So that it will turns into 0.3 into 10. It will turns 3. You'll get the 3 by 10. Is it yes or no? Yes, everybody? All of you?
Yes, sir.
Now, in mathematics, if you are multiplying and dividing at a time with the same number, remains the value will never change. Is it right or wrong? Is it right or wrong? Is the value will change if we multiply with multiply and divide with any number? Is the value will change? That is what my question.
No, sir.
No. Now same way for the same equation. First what we got? Velocity is directly proportional to r by t. Now I have been done square on equation 2 on both the sides. So what is the equation you got? Open your mouth and tell me what is the equation you got. You don't know present and how they will respond. They will never give chance to me to speak. So what is that? Velocity square is directly proportional to square of radius divided by square of time period. Is it yes, guys?
Yes, sir.
Now, if we multiply as well as divide the right side of this relation by r, all of you do that and tell me how it will come. If you multiply, write it. If you multiply as well as divide if you multiply, the same principle I am applying. If we multiply and divide, only which side? Right side or left side? Right side. If you multiply and divide, only right side. Right side of this relation by r, then what will get? Metakshri, can you tell me? Open your mouth and tell me, Hari. I want to multiply this right side alone and divide with r. Then what will happen? Equation. Anybody can tell me? Then
We will get the same value.
v square directly proportional to r square by t square, and I am multiplying and dividing with what? Multiplying and dividing with what? R. Is it right or wrong? Multiplying and dividing with r. Is it okay, guys?
Yes, sir.
Yes or no?
Yes, sir.
Yes. So that is what it is. Now, observe very carefully. Here onwards, the twist will be very nice. So what is Kepler's law? Now, check it, everybody, this one. Now, can I do that one? This modify it as a v square directly proportional to r square into r. What is the mathematics formula? 2 square into 2. Can I write as a 2 cube? Can I write it or
Yes.
not? Yes, same way. So what will come here? R square into r, which will turns into r cube divided by t square into 1 by r. Is it right or wrong, Mr. Akilan? Ready? Yes, please.
Yes, sir.
Yes. Now, something from the Kepler's law, something is constant. Kepler's third law. What is constant? You studied already today also. Kepler's third law. What is Kepler's third law? Kepler's third law.
The T1 square is constant, sir. Divided by R1 cube is constant.
Or else we can say here what we got. Check it here. R cube divided by t square is equals to constant. Is it yes or no? That is only the Kepler's third law. Is it yes or no?
Yes, sir.
Yes. The same way we are attaining here. So now what we got the equation? Check it, everybody. V square directly proportional to r cube divided by t square into 1 by r. So here something is constant. What is constant? By the
R1 by T
yes.
square.
By Kepler's third law of planetary motion, the factor RQ by T square is constant. So that the relation will be modified into what? Somebody is making sound. So from the Kepler's third law, from the Kepler's third law, R cube by T square is constant. So the equation will be modified into what? V square is directly proportional to 1 by R. So let me assume this is what the equation 3. Is it okay, guys? Is it okay?
Okay, sir.
Yes, please.
Yes, sir.
Nobody will answer. Is it okay, ma?
Yes, yes, sir.
Now, observe very carefully. So I can say V square means 1 by R. And you can see here, it is not exactly here, even I should not keep proportionality. It should come something because R cube by T square is constant. Constant into proportionality. What we should replace? We'll replace with what? Constant into proportionality. Replace with what? Yes, please. We'll replace with what? Equals to sign.
Equal.
Remember, proportionality constant. We will replace with the equals to sign. That is what we have to remember. So V square means what is the formula? V square is equals to 1 by R. Understand? Now this is equation 3. Now substitute equation 3 in equation 1. Anybody can substitute and tell me what will come? Equation 3 in equation 1. What is equation 1? What is equation 1? What is equation 1? F is directly proportional to what is equation 1, guys? V squared. So that is what it is. So that is what the equation. So substitute equation 3 in equation 1. All of you should substitute. What will come? F is directly proportional to V square by R is the equation 1. Now we know that. What do you mean by V square? Everybody should tell me. What do you mean by V square? We got it just now. What do you mean by V square?
1 by R.
1 by R.
1 by R.
Yes, that's all. So I can write F is directly proportional to 1 by R divided by R. Is it right or wrong? So
Yes, sir.
nothing is there means here 1 is there. So 1 by R divided by R, nothing is there means 1. So that it directly proportional to, it will turns into 1 by R into 1 by R. Is it right or wrong?
Yes, sir.
Yes, all of you. So F is directly proportional to 1 by 1 into 1, 1. R into R.
R square.
That is only what is that called as? What is this called as? Yes, please. What is that called as? Inverse square law. What is to call? Inverse square law. This is how a Newton's guess from whom? With the help of Kepler's third law. This person has guessed this law. That is only we used to say Newton's law, inverse square rule. That is what how Newton guessed the universal law of gravitation with the help of Kepler's laws. Now, are you understanding the connectivity between Kepler's laws and universal law of gravitation? Yes, please. All of you.
Yes, sir.
That is. So please take your time and solve. It's very simple. If you'll understand what is the circular motion formula? Circular motion velocity formula 2 pi r by t. And centripetal force, what is the formula? Centripetal force, what is the formula? Mass into velocity square by r. If you'll remember these two, that is enough to solve this derivation. So this is what it is. Hope everybody understand. So please, anybody is having any doubt, please kindly ask me, or else you start solving from the beginning. I will display and you can do it. So this is what the first. Have you written this one? I hope everybody written this. Then come back to this one, consider and write it neatly. Have you understand everybody? Divya, Mitakshri, Kaushik Ram? Yeah. Okay. Akilan, any doubt, Akilan?
No, sir.
Okay, solve it. Try to solve. Harini, you Harini?
No, sir.
Okay, good. Solve it. If you'll solve, then only I will understand either you are able to solve or not. Do it. Harish Jairas.
Yes, sir. Doing, sir.
Yeah, solve. Everybody try to solve your own. Once it is completed, tell me, Hari. I will go back. We'll go down. Here, everybody. Can I go down? Next one, this one. It's very simple. Only thing is understanding. How you are understanding is only matters. Always remember, I am giving the extra knowledge here. Centripetal force always depends square of the object speed and inversely on the radius of the circle. Is it okay, everybody? Yes, please. Centripetal force. That is because I taught, as I told you, second method I will teach you, correct? I will teach you that so that you can understand. Is it okay, guys?
Yes, sir.
Yes. Of course, it is late today. Harish, you have a school today? Harish Jairas?
Yes, sir.
Yes, of course. Okay, well, what is your school time?
7:50, sir.
Oh, okay. That's fine then. You carry on. Then later, when you come, you can write. Have you understand this one?
Yes, sir.
Of course. Actually, today we have a local holiday. That is why. So you proceed. Once it is over, you solve it. You can leave from the meeting. Everybody, have you solved, Mr. Johan? Gokul?
Yes, sir.
Once you completed, do it. But actually, shall we go with another method? Yes, please. All of you. If you're ready means I will go with that. Second method. It's a very simple. Shall we go with that? Okay. So now second method, see. These are all the things I will combine and I will make it into a simple formula. So where you will get the direct answer. So that is what. So as we consider inverse square law and its deduction, how this Newton guess, if you'll observe, while arriving at the inverse square law for forces under gravitation, remember, Newton made some assumptions in the planetary motion. What is the first assumption he made? Elliptical shape he considered as a what shape? Elliptical shape he considered as a what shape?
Circular shape.
That is the first assumption. So you have to remember that. So to derive the Newton's inverse square law, Newton made some assumptions. That is what first he considered that planets are revolving in the circular path, and Newton accounted the gravitational force between the sun and the planet for the centripetal force of the planet revolving in its orbit. So he has been made these two assumptions. He has been considering the orbits are in circular, and the second one, the planets are revolving around the sun is due to the centripetal force of the sun around the revolving in its orbits, making the planets revolving in its orbit. So he has been found that the magnitude of the centripetal force of a planet in its orbit F. What is the centripetal force F? What is the centripetal force F? So Newton made two things. One is he considered a circular orbit, and the second one is centripetal force is acting. Centripetal force is acting, and he has been centripetal force. What is the formula for centripetal force? Everybody. So the
Mass
magnitude
into
of centripetal
distance.
force is equals to, everybody open mouth and tell me what is that? Mass of the planet into velocity of the square of velocity of the planet divided by what? Radius between the sun and the planet. That is what he has been considered. Radius of the orbit. Now, if we'll take, as we know, magnitude of the orbital velocity. What is the orbital velocity of the planet? That is what? Circular motion. We can say orbital velocity. Circular motion. What is the orbital velocity formula? Orbital velocity formula, guys. Orbital velocity formula, V is equals to circular motion. V is equals to 2 pi r by t. That's all. That is the assumptions he made. Now simply it will get, you see, 2 pi r by t. Now t is called as what here? T is called as time period to retake revolve. Understand everybody? And 2 pi r is the, what is the 2 pi r? Mr. Reddy, Mr. Hari, Gokul, 2 pi r.
Circumference.
Yes, circumference of the orbit. T means time period to take complete revolution, period of revolution. Period of revolution we can say, time period of revolution. Revolution means what? To take one complete rotation. So this is what it is. Now V is equals to what, Mitaksri, Divya? V is equals to 2 pi r by 2 pi r by T. Is it okay, guys? That is what. Now, substitute, let me consider. So we can say V is equals to 2 pi r by T. Now, this is what for what velocity? Everybody should answer. Orbital velocity. And this force is what? What is this force? Centripetal force. What is this force? What is this force?
Centripetal.
Let me consider this is equation 1 and this is equation 2. Is it okay, everybody? Now, I want to say you that I will say you after the deduction. Now, substitute equation 2 in equation 1. What will happen, guys? Substitute equation 2 in equation 1. Let me see who will say first. Just respond. F is equals to what will come? 2 pi. R means what, guys? Sorry, mass. Sorry, Emma. V, first M. M into V means what? V square it is, but we have only V here. So V means what we can make? 2 pi r by T whole square divided by T. Is it okay? Sorry, divided by R. Is it yes, guys? Yes, I'm substituting in place of V square. You can see here V, I am substituting 2 pi r by T. Is it okay, Hari?
Yes, sir.
Kaushik, have you understand? 2 pi r by T. I am substituting in place of V. See here V square I have. So I am substituting V value 2 pi r by T. Is it okay, guys? Respond.
Yes,
Now, what is the equation? You should tell me. Next step. F is equals to M only into this is belongs to both. A by B whole square means mathematics. What we can write? A square by B square. Same way, tell me this one. What will happen? Everybody.
4
2
r square, sir.
whole square divided by T square divided by R. So this is what will happen. Now, next step. M into, here nothing is there means 1 will be. So M into, this 2 is belongs to both. AB whole square means I can write A square, B square. So what will happen? Everybody should tell me. 2 square, 4, pi square, R square. Is it right or wrong, guys?
Yes, sir.
Yes. Divided by this T square, and R will also come up. So that what will become? It will become into 1 by R. So what is the final formula will turns now? Everybody answer. So F is equals to M into 4 pi R square, 4 pi square R square divided by T square into R, T square R. Is it okay, Hari? Ready? Gokul? Sulabha? Is it right or wrong?
Yes, sir.
Everybody? Any doubt? Clear, guys? Hitakshri?
Yes, sir.
Now,
Yes, sir.
as we all know that something is constant, mass is constant, 4 is constant, pi square is constant. Can I keep all are separately? All are constant only, correct? 4 into pi square into m. Is it a constant or not? All are.
Yes, sir.
Into what is remaining? Tell me what is remaining? R square divided by t square r. Is it right or wrong?
Yes, sir.
Yes. Now multiply and divide. Multiply and divide numerator equation, above equation with what? Anybody can tell me? Above equation with what? With what, guys? With
R,
what?
sir.
R. So that is what? So 4 pi square m into r square into r divided by t square into r. So what is the formula will turns? You should say me, see this much simple things also you cannot say me what I can do. So 4 pi square m, this is what entire things is called as constant. This fully things is constant. Now r square into r square into r cube divided by t square, r into r into
R square.
r square. Now look into this one, answer is over, which is equals to 4 pi square m, this one r cube by t square into 1 by r square. Can I write it or not? Can I write it or not?
Yes, sir.
Yes. Now by this time your bulb should glow. From the Kepler's third laws, Kepler's third law, what is constant? R cube by t square is equals to what? Constant. And as well as already we know that 4 pi square m is also what? 4 pi m is also what? Constant only. So f is equals to constant. Entire thing will become constant. Understanding? Into 1 by r square. So equals to constant we can replace with what sign?
Proportionality sign.
Proportional sign. This is only called as what? Inverse square rule. Is it okay, guys? So inverse square law. Understand, Divya? Akilan?
Yes, sir.
Just substituting. That's all. This is only f is directly proportional to 1 by r square. So this is only known as inverse square law. I hope, which is easy for you, first one or second one? Don't say me second one. Okay. Is it okay, guys?
Yes, sir.
That is what it is. Any doubt, anybody can ask. And always remember, note and remember for your future and as well as for NTS exams and all, note centripetal force. Do you understand it? Or the acceleration, centripetal acceleration is depends on directly on the square of the object speed and inversely on the radius of the circle. That is what centripetal acceleration, all of you should remember. AC means what? Centripetal acceleration. Centripetal acceleration is equals to V square by R. Is it okay, Hari? Centripetal acceleration. You want to find the acceleration. You know till now velocity only. Is it yes or no, guys? Circular path. You know the velocity formula. What is the velocity formula? 2 pi r by t. Is it yes or no? Velocity formula 2 pi r by t. But acceleration v square by r. That is what centripetal acceleration. And as well as centripetal acceleration of an object traveling in a circular can be expressed in the form of time period. If the time period also you know, then 4 pi square r by t square. That is the formula. So what is the formula? If you know time period is given 4 pi square r divided by t square. This is the formula for what purpose, guys? Centripetal acceleration. This formula only we derived here. Do you notice it here? 4 pi pi square here before. You can check it here. You'll get it. All the formulas before squaring and all, we'll get the same formulas. Understand, everybody? So we have to do the same thing. So what is the acceleration? If the time period is given, acceleration is equals to 4 pi square r by t square. If they have given centripetal force for an object traveling in a circular can also be expressed as a function of its period, time period, then we can say like this. Any doubt? Anybody can ask. Is it okay, guys? Clear?
Yes, sir.
That is what. So this is what inverse square law. Hope everybody understand the two methods. I think second one is, this will go simply, but you have to consider, Newton considered 2 points. What Newton consider? Anybody can tell me? To derive the inverse square law, what changes Newton made? What changes Newton made? Newton made a few changes. What is that? One is he considered the orbit of a planet to be circular. Next one, he accounted the gravitational force between the sun and the planet is for what force? Centripetal force of the planet revolving in its orbit. The force he considered as centripetal force. And as we know, centripetal force, what is the formula, guys? What is the centripetal formula? mv square by r. And as we know, what is the orbital velocity formula? When the body is revolving in a circular path, what is the orbital velocity formula?
2 pi r by time taken.
2 pi r by time period, means time period of revolution. R means circumference of the, 2 pi r means circumference of the orbit. T means time period of revolution. That is what it is. Hope everybody understand this. Any doubt? Anybody can ask me. This is what the two methods, which is easy for you, you can learn. This is how the Newton gets the inverse square law from Kepler's third law of planetary motion. Is it okay, guys?
Yes, sir.
Yes. Any doubt, anybody can ask me, or else you can solve. So this is all about it. I will send the PDF also. Please learn. Most of them they'll face difficulty to understand. But as we went with the two methods, which is easy for you, whatever it is, consider, you can make it. But if you are following the second method also, you have to write Newton considered the few changes. That is what? Circular path, elliptical path taken as circular path, so that always radius is constant between the planet and the sun. And the time period, that is what time period, centripetal force, and as well as what force. Next one, velocity, orbital velocity. These all the things he has been considered. Then only how to go with the substitution. Is it okay? Everybody? That is what it is. Please kindly solve. If you have any doubt, you can ask me. Understand, Mr. Kaushik? Harini? Okay. So this is all about it. I will send the PDF also. Medakshri, understand? Medakshri, any doubt? Medakshri?
No doubt, sir.
Okay. Solve it. Very, very important. This chapter will make you always differs from your friends and you in our higher classes also. 11 and 12. Most difficult chapters, and learn very carefully. Per day, one single concept you learn also. You can easily will do in the exam. That is what my expectations. Okay. So please try to learn. Any doubt, please kindly ask me. So thank you all of you. We'll meet in the next class.